Lesson 3-4, Direct Variation. A direct variation is described by an equation of the form y equals kx, where x does not equal 0. The equation illustrates a constant rate of change, and the x is the constant variation or the constant of proportionality. We are able to use any variable in this example. It does not have to be k, but that's just the variable that they're choosing to use here to represent the constant rate of change. So if we are given an example like this one, and it says, name the constant variation. Based on the definition, we know that k is the constant variation. And k in this equation, because our equation was y equals kx, k would be the number before the x, so my constant variation would be 1/4. We would also be able to find the slope in this because we could use y2 minus y1 over x2 minus x1, which would equal 1/4. So our slope and our constant variation are equal to each other. So now we're going to look at how we can graph direct variations. So we first want to determine the slope, which we know is the same as the constant variation. So in this case, the slope would be -6. But we know that we have to put it in form of rise over run, so it would be -6 over 1. So if we have our graph, unless it tells you, you always want to start at 0, 0. So we graph the point 0, 0, which is in the center, and then from there, we use our slope and we graph more. So it tells us that we are going to rise -6. So that means we go 1, 2, 3, 4, 5, 6. And then it tells us to run +1. So our new point would be right here. So you would be able to graph the line connecting those 2 points, and that would be your line for the direct variation y equals -6x. Pause the video to graph the direct variations below. The first example, you again want to identify the slope, which would be this number. So we want to start at 0, 0, and we rise 2, so we go up 2, and we run 3. 1, 2, 3. And so we have our new point. Then we connect our points, and that would be your line. For number 2, you have y equals -5. -5 is your constant variation. We put it over 1 and it becomes our slope. So we graph 0, 0. Then we rise -5. So that means that we go 1, 2, 3, 4, 5 in the negative direction. And then we run 1. So our new point is down here. So then we use those 2 points to connect to graph our line. So just to kind of review, direct variation equations are the form y equals kx, where k is not equal to 0. The graph of y equals kx always passes through the origin. So the graph always passes through the origin, which is that 0, 0. And the slope is positive if k is greater than 0. So if you have k and it's greater than 0, then the slope is positive. If you have a k that is less than 0, then your graph is negative. So we can also write and solve direct variations if they're in word form. So you may see where it says, suppose y varies directly as x and y equals 72 and x equals 8. So we know that our direct variation form is y equals kx, and then you just plug in what you know. So you know that y is 72 and x is 8, so that means that we're solving for k. So you divide both sides by 8, and you get k equals 9. So that means that the direct variation here would be y equals 9x. So once you have the direct variation equation, then you can use it to solve for a variable. So here it says use the direct variation equation to find x when y is 63. So we plug in y and we solve. Divide both sides by 9, and you get x equals 7 when y is 63. Pause the video to try the example below. So to complete this, you first want to write the direct variation equation that relates x and y. So remember the equation is y equals kx, y is 98, k is what you're trying to solve, and x is 14. So we divide both sides by 14, and we get k equals 7. From there, you use the direct variation equation to find x or y. Well, in this case, they want us to find y when x is negative 4. So y equals the k, which is 7, and x, which is negative 4. So y equals negative 28. Pause the video to complete the lesson review. Make sure you show me this lesson review for verification of this video.